Hey, hello, geometry students. Welcome to our second lesson of chapter 8. Now we're getting real interesting. We're getting into trigonometry, and we're going to be talking about these things called trig ratios. All right, we just got off a whole chapter on ratios, so we can kind of know what those are. Comparison of two different quantities. And so when we add the trig to it, we'll be talking about triangle ratios. And so that's actually one of our definitions. Our first one here is trig ratios, and that is there a comparison of two sides of and I'll emphasize here, a right triangle. So we're talking specifically about right triangles. So what do we mean by comparison of two sides of a right triangle? Well, for example, let me draw that a little better. So we have a right triangle. Typically, we'll call the legs A and B, and we'll call the hypotenuse, as we've learned, C. And so what a trig ratio would be something that basically compares, let's say, A over C. Or maybe it would say B over C. Or maybe it would be B over A. I'm going to keep it general for this definition, but it's what we found is that with a right triangle, there is a direct relationship between the different sides or the ratios of these right triangles and their angles. And we're going to learn that we can use right triangle trigonometry or these trig ratios to find missing sides and missing angles of right triangles, all based on setting up particular, we'll draw a line under that, particular ratios, okay? One side over another side. And the next three definitions are three specific trig ratios that you'll want to learn and become very familiar with throughout this chapter. And again, you're going to use them a lot in the rest of this book and also into Algebra 2. And then if you continue beyond Algebra 2 into pre-calc and all that good stuff. Okay, so let's talk about what are three specific trig ratios. So we have sine, cosine, and tangent. And each one of these is a specific ratio of one side of a right triangle to another. So for each one, I will go ahead and just redraw our right triangle. We'll start with sine. So we have a right triangle. We're going to just go again with A, B, and C. And so sine, which is abbreviated sin, we don't say sin, but we abbreviate it. So you don't usually write the E. And what that does is you take sine of a certain angle. To do the angle, we have this thing called theta. Theta looks like a little Pokeball or an O with a line through it. It's the Greek letter. And that is an angle. So in other words, the sine of a particular angle is equal to the opposite side from that angle over the hypotenuse. So the ratio is the opposite side, oops, got to spell correctly. It's the opposite side from the angle divided by the hypotenuse. Or, so for example, let's go ahead and write let's get our angles here. Notice when we write triangles, capital letters are used for the angles or the vertexes, and then the lowercase letters are used for the sides. And notice there will always be across from their matching, oops, so in fact I did this wrong. C should be across from C, A should be across from A, so this should be A right here, and then B should be across from B. So that would be more accurate like that. And so if I say, for example, I want sine of angle A, you have to pick a specific angle you're looking at it from. It's going to be the opposite of A, which in this case is A, because A is across from it. That's considered opposite. So sine of A would be A over the hypotenuse. Now the hypotenuse, as you can see, is C. So in this case, the sine ratio for angle A would be A over C, because that's the opposite over the hypotenuse. And which one you call opposite depends on which angle you're referencing. For example, if I were to say sine of B, then I would be looking at the side opposite from angle B, which is B, over the hypotenuse. Now, the nice thing is the hypotenuse never changes. It's always the long side across from the 90 degrees. So that would also be B over, whoops. That would be B over C. So we'll get into detail in this in class. We'll do some examples, but anyway, sine is opposite over hypotenuse. Whereas if we talk about cosine down here, I'll do this one in blue. Set it up the same way. We've got C, B, B. Cosine is equal to adjacent over hypotenuse. Now, adjacent means next to. So in this case, once you pick the angle that you're going to set a ratio up of, then you're going to look for the side that's right next to it. So if I were to say cosine of A, so that would be right here, well, what side is right next to it? B. So cosine of A is B over C. Notice C is the hypotenuse. Also, you can notice that C is next to angle A, but C is the hypotenuse. The hypotenuse will never be the opposite or the adjacent leg. So cosine of A is B over C, and cosine of B would be A, because A is right here adjacent to the angle B, A over C. And we'll practice that. That might just look like a big alphabetic gobbledygook. And if it does to you, we'll clarify that in class. But just remember, cosine is adjacent over hypotenuse, while sine is opposite over hypotenuse. I'm going to give you a trick in a moment for how to remember these. So then our last trig ratio is tangent. Tangent, and let me write these in again real quick. So side B, side C, side A. Tangent of an angle, or theta, is equal to opposite over adjacent. So this one does not involve the hypotenuse. It involves the two legs. And so we have opposite over adjacent. So that means if I were to have tangent of A, opposite of A is side A, and adjacent to A, or next to it, is B. And again, I'm never going to say C, even though C kind of looks adjacent. But I'm going to, because you're never going to call the hypotenuse adjacent or opposite. So tangent of A would be A over B, the opposite angle side from the angle, and then the one next to it. Or in reverse, tangent of B would be B over A, because B is opposite and A is adjacent. Okay, so you've got sine, cosine, and tangent. And the little trick to learn these things, because again, it seems like a jumble, is I want you to learn SOHCAHTOA. Maybe you learned this in Algebra 1. That would be great if you did. SOHCAHTOA, I teach it as a simple chant. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, because that gets stuck in your head. And then in that SOHCAHTOA are the three ratios we just described. Sine, it's opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so the first letter tells you which trig ratio it applies to. The next letter is which one's the top of the ratio. The next letter is which one is the bottom of the ratio. So sleep on that tonight. SOHCAHTOA, SOHCAHTOA. You're welcome. Because that's your first goal, is to memorize them and not get them mixed up. Then we'll work on applying them. So let's look at our questions. First question is, how do you know which side is the hypotenuse? How do you know which side is adjacent? Which side is opposite? Great question, Mr. Mefford. Let's go ahead and label our triangle here. I'm going to call this one ABC, which means side C is here, side little a is here, side little b is here. So start with the hypotenuse. How do I know which is the hypotenuse? Well, it's always the longest side. It's always across from the right angle, right? And it's also labeled most of the time, traditionally, C. Okay, so C will usually designate your hypotenuse. It's always going to be the longest side, and it's always going to be across from the right angle. So C is set there. Also, as I've already said, it will never be the opposite or the adjacent side. This right here, okay, the hypotenuse. Now, how do you know which is opposite versus adjacent? Okay, that is important because it depends on what we call the reference angle. Okay, it depends on the reference angle. And that's what I mean by, if I look at the triangle here, how do I know whether A or B is my adjacent or opposite? The key is, well, where am I looking from? If I'm talking about the sine, cosine, or tangent of B, well, then that makes A my adjacent, and it makes my B the opposite. Okay? Whereas if my reference angle is A, then that makes B my adjacent, and that makes my A the opposite. So that will, opposite and adjacent will shift depending on which reference angle you are looking at, okay? Whereas C will always be your hypotenuse. Okay, let's look at number two. Number two just gets you used to the structure of a trig ratio. It says, in trig ratios, what quantity always goes as a ratio? Angles or sides, okay? So in other words, here's a typical trig ratio. And this is asking, so what's always going to be a ratio right here? A ratio, remember, is just a type of fraction. What are those values? So in this case, x and y, what do they always represent? They always represent side lengths. Okay, so if it's written as a fraction, the side lengths are always there. Your x and y, maybe they're a, b, or c. They could be various letters at times. But if it's written on the other side of the equal sign, away from the ratio name, in this case sine, that's, you know, those x and y have to be side lengths. Whereas our little Pokeball, theta, that it's asking, which always is calculated with sine, cosine, or tangent, where you would actually, you could take a calculator, if you have a scientific one, you would say sine of, and you put a number in, cosine of, and you put a number in. That number is what we call theta. That will always be an angle measurement, okay? Or it'll usually have degrees, okay? So angle measurement goes right next to the sine, whereas the part on the other side of the equal sign written as a fraction, or a lot of times, sometimes we'll see it's written as a decimal. Those represent side lengths. Okay, so that's just kind of getting you used to how, because this is probably new territory for a lot of you in terms of you've never seen anything like this before. So side lengths are the fractional part. Angle is always what goes next to the sine, cosine, or the tangent. So then part three, I just wanted you to practice some basic problems out of the book to familiarize yourself with trig ratios. So let's go ahead and take a look at them. Number two says triangle MNP, where M is the right angle. So I've drawn that. Write the tangent of, and notice here they're going to give us a reference angle. They don't just say right tangent. Well, we can't. We need a reference angle. So they say write the tangent angle of angle N as a ratio of side lengths. Okay, so in other words, which side over which side gives us tangent of N? All right, well, let's do it. So the most important thing is we know our reference point. We're looking from angle N. Let's go ahead and label our sides. If that's angle N, then this is side N. If this is angle M down here, then this is the hypotenuse is side M. And if that top one's P, then down here is side P. Okay, so tangent of N is always SOHCAHTOA, TOA. Tangent is always opposite over adjacent. So from my reference point of N, who's opposite? N. So that means tangent of N equals little n over adjacent. Well, that means that one's here. So N over P. Okay, that would be opposite. This would be adjacent. So tangent of n would be written as n over p. Okay, if it was cosine, I would do opposite over hypotenuse. That would be n over m. If I wrote sine, I'm sorry, cosine would be ka, would be adjacent, p over m. Sine would be opposite over hypotenuse. That would be n over m. So depending on which one you use the SOHCAHTOA. In this case, they say tangent. So we're doing opposite over adjacent, n over p. And obviously then, if my reference angle was p, that would change what I was doing also, because then different sides would be opposite and adjacent. All right, let's try another one. Number 4. Write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. Okay, and they've given us this triangle, a 3, 4, 5 triangle. And then they've said for number 4, tangent of A. So again, there it is, key. We've got our reference angle. Let's switch to blue here. A is my reference angle, and I'm supposed to do, again, it's tangent. Well, again, tangent, TOA, tangent of A equals opposite over adjacent. So which number is opposite from A? Right? There, it's my 3. So tangent of A equals 3 over, which one's adjacent? Right there, 4. So the right ratio is 3 over 4. Right? So they said write it as a fraction. There it is. I can't reduce it. What's the decimal for 3 over 4? Well, if you're not sure, just do 3 divided by 4 on a calculator, but it is 3/4, so it's 0.75. Right? So that's tangent of A for this triangle. Again, if they did cosine, I would look for the appropriate other sides, and I'd write a fraction with those numbers. Okay? With this case, it's tangent of A. So 3 over 4. All right, let's try number 12. 12 is an example of, notice they're giving us a degree. They're saying use your calculator to find the trig ratio to the nearest hundredth. Alrighty, so that means now they're not giving us side lengths to write a ratio with. They're actually giving us what I call a degree to crunch. And I call it crunch because you got to put it in your calculator. So here's my calculator. I've switched it to scientific mode. So it's got sine and cosine on it. And it says, how do I calculate tangent of 67? Well, all I have to do is simply plug in tangent of 67. And then I'm going to hit equals. This is not something you can know off the top of your head. So I'm going to hit it. And let's see, make sure I'm in the right mode. Yes, I am. And so now I can see I get a decimal. Really, they're always going to be these long. Whenever you take a sine or cosine of a degree, you're usually, not always, going to get a pretty long irrational fraction. So they say round it to the nearest hundredth. So we're going to say 2.36. So this was just something I did in my calculator, and I get approximately 2.36. And so what that means, that is the fraction-y thing of the two sides. That when they divided the fraction, they got 2.36 and all the other numbers along. But so whenever you see take a tangent, cosine, or sine of a degree, that's a really easy problem. You're just going to put it in your calculator and crunch it. We will talk about a calculator feature called degrees and radians. There can be a setting you need to make sure your calculator is in so that it's doing these calculations the way you want them to. And we'll cover that in class. And if you don't have a calculator yet, this chapter is a good chapter to get yourself a calculator. Okay, you'll need one. And I don't want you using your phones. Okay, so that's how you just calculate the degrees. If they actually give you the degrees, 2.36. Okay, and so now number 18 is going to tie it all together. It's your most basic right triangle trigonometry question. And that is, they give us a right triangle, they give us a degree. You can see that angle A is 23 degrees, and they give us the hypotenuse as 4 inches. And then they say, find side BC. Now they say side BC, so that's this side. I've already I don't like using these 2-letter designations, so I would go ahead and call that's side A, because it's across from angle A. So just so you know, BC is the same as side A. So that's what I'm going to go ahead and do in this problem. In this case, look, they messed up our letters. This side is C, and the 4 side is side B. Okay, so how on earth do how do we do this? How am I going to find this side right here? Well, the trick is you pick a trig ratio that combines the angle they give you with the side they give you and the side you want. So let's take a look. They've given us side angle A. We know the hypotenuse is 4, and we want to find A. So let's see. From angle A, what is side A? Side A, is it opposite? Is it hypotenuse? Or is it adjacent? It's not hypotenuse because that's B there with the 4 inches. Is it next to or across from? Well, look, it's across. So that means A is the opposite. And the other one I know, so this is opposite. And this here is hypotenuse. So that means the trig ratio I'm going to use to solve this problem is the one that combines opposite and hypotenuse. SOHCAHTOA, SOHCAHTOA. Which one does opposite and hypotenuse? It's SO. Okay. So is sine is opposite over hypotenuse. So that means I want to use sine. That's kind of the real trick, is being able to look at the information they give you and put, like I said, match the angle to the sides that you're using, and say, okay, do I use sine, cosine, or tangent? Well, in this case, because I have the opposite side I want to know and the hypotenuse that I do know, I want to use sine. And so the way we set this up is we write sine. What goes always next to sine? It's not the side lengths, it's the degrees. So sine of 23 degrees is equal to, and then on the other side is always a fraction or a ratio of the sides. And since sine is opposite over hypotenuse, I'm going to do A over 4. Okay, so you can see what I plugged in there. I've got the sine with the degrees, and then I've got it equal to the right ratio, which in this case is opposite over adjacent, or A over 4. So can we now it's an algebra problem. Again, maybe a strange one you haven't seen before, but let's take a look at this. Can we calculate sine of 23? Yes, using my little calculator friend. I simply write sine of 23, okay, as so. I'm going to hit equals, and I get a very wonderful number. You're going to get used to these numbers. 0.3907. I always do 4 decimal places. 0.3907. So I just simplified sine of 23. I crunched it to 0.3907. And that is now equal to A divided by 4. Okay, can you see how we're going to solve this problem now? Now that we know what that is, I'm just going to multiply both sides by 4. And I will have side A. So I'm just going to take this number. I didn't even delete it. I leave it on there. And I'm just going to hit times 4 equals. And I get 1.562. So there we go. 1.5, it says to the nearest hundredth. So 1.56. So that means A is equal to, or approximately, 1.56. So that means this side length here is 1.56. So I just found the length of that side using my right triangle trig ratio. Okay, it's going to seem overwhelming at first, memorizing sine, cosine, and tangent, putting them into an equation like I just showed you and solving them, but I promise we're going to do enough of these that you're going to get very good at them. And they're very important moving forward. And so it's not something you're going to want to just say, I'll skip this part and tune in later. No, there will be much pain and suffering if you do that. So rewind the video, watch it again. I won't just put a recap on this right now. I'm going to end the video and I'll talk to you in class. But these are trig ratios, and they're solving sides and angles of right triangles using sine, cosine, and tangent. All right, see you soon. We're going to have a lot of fun.